Right, okay, so we're on page 460. We'll look at exercise 13E and we'll have a look at question 1. All right. We'll do all of it. So, in the question, it says that sine theta equals 5/6. And then it asks you, using that, well actually there's another piece of information, we'll discuss this, where it says theta is between that and 90. Okay, 0 and 90. Now in these questions, we don't have to consider anything, but you'll notice that for each one, question 1, 2, 3, there's always a 90-degree split, unless it's cos, which is then at 180 degree. And any ideas why? Because in sine, if you only consider 90 degrees worth, there is only ever going to be one solution.
0.
Oh, well, it's not for 0. So if you think about it, for sine, right, like this, if I break it up into 90-degree blocks, let's say I want a solution there, it's either got one solution or, I guess like you said, no solutions. If I went to 180 degrees, I'd then have potentially 2 solutions. So for all these questions, they basically cut it so there is only one solution. If it was cosine, we can actually go up to 180 degrees, from 0 to 180, and only have one solution to something. Okay. Now, for sine, I could do the same thing, but minus 90 up to 90, or 90 up to 270, and so on. That would still only give one solution. So when it says this domain, if the domain, that's what it's doing. Right? You have to check, but if it gives a domain like that, you're thinking, right, there is only one solution in this case, which makes it simple. Right? Okay, so we're told that sine theta equals 5/6. We've got to find what sine of 2 theta will be. Okay. Now it's not okay just to go on. It's 2 lots of 5/6. It doesn't work that way, does it? All right. So we've got to use our identities. So sine 2 theta could be rewritten as
2 sine cos sine theta.
So 2 sine theta cos theta. Yeah, that's one of them. Right. So to know this, well, I know sine theta. I've just got to work out cos theta.
One of them, there are multiple, for sine 2 theta, there are multiple ways to solve it.
Yeah, there's more.
It doesn't matter which one you choose, it doesn't matter or it doesn't matter.
It's which one applies better. You know, which one you've got the information for. Well, some of them will be more useful than others in different situations. Depends what you're given, depends where you want to get to.
It's for sine only, there is only one equation.
For sine 2 theta, there's only one, isn't there? For cosine, you've got 3 options, I think. But sine 2 theta is 2 sine cos theta. Now, the question is, we know sine of theta, so actually we can already put in it's 2 times 5/6. The question is, what's cos of theta? Now, there is another identity that you can use to work that out, but actually what I'm going to do, it might be quicker or easier for you to understand. I'm just going to draw myself a little right angle triangle, put theta, and if I know that sine of theta is 5/6, sine is what? Opposite over hypotenuse. So I can just write 5/6 and then solve for that side using Pythagoras' theorem, which in this case would be 36 minus 25 square root, so root 11. Okay, so that's root 11. Right. So there's another way to do it. The book doesn't do it that way, but I've done it because that's what's actually happening when they use the the identity. They're just solving it, finding it using Pythagoras system. Right? You're all happy with the root 11 thing, I take it. I don't need to go into detail. So then, using that, we've then just got times. Cosine is root 11 over 6. Right? So then I've got 2 cancels with that, so it becomes 3. So I've got 5 root 11 over 18. So that's sine 2.
Why is it over 6? Yeah, because it was cos.
Because cos theta is adjacent over hypotenuse. Okay?
Wait. Why do you cancel the 2 over 6? Oh, wait, never mind.
Just simple fraction stuff, yeah?
Yep. No.
No. Okay, so this becomes,
Why don't you cancel the other?
it's 2 over 1, so it becomes 2 times 5 times root 11 all over 6 times 6. So if you want 10 root 11 over 36, sorry, and then there's a common factor of 2, so that becomes 5, that becomes 18, because you've divided top and bottom by 2.
Oh, okay.
So I might as well just do it
Yeah, okay.
at the start. That's all I do. Right. Part B then is cos of 2 theta. So what's the identity for cos of 2 theta that we're going to use? 1 minus 2 sine squared theta. Now the reason why I've done that is because I know what sine of theta is. So we've got cos of 2 theta is 1 minus 2 times 5 over 6 squared. Alright? So we've there got cos of 2 theta is 1 minus 2 times 25 is 50 over 36.
And what's the other one? I have a question. Do we have to know how to get to the sine 2 theta? How do you get to that? Isn't the equation we use at the start?
How do you get that?
Yeah.
The identity.
Yeah.
That's the whole point of the chapter, learning the identities.
You know how to get to it.
No. You need to know it. It's in your formula. Yeah? That's what you were saying. Could I show you how it's derived? And I said that's not really the problem. Okay, so we've got 1 minus 50 over 36, so that's the same as 1 minus 25 over 18. Okay, so we've got cos 2 theta is actually minus 7 over 18. Everyone happy with why 1 minus 25 over 18 becomes minus 7 over 18? No? Okay, fine. Because 1 is 25 over, 18 over 18. Could be anything over it, as long as it's the same. So I've then done 18 over 18 subtract 25 over 18. Which,
Okay.
yeah. Alright, then finally, which is why actually it's worth going through because I don't think they really do this properly in the book, tan of 2 theta, okay, well tan of 2 theta is sine of 2 theta over cos of 2 theta. Same as, it's easy then because tan is just sine over cos, and if you've got 2 theta, it's the other two are 2 thetas as well. Okay. So that just leaves us with the answers that we've got. So that one was minus 7 over 18, and the other one was 5 root 11 over 18. And again, just from basic rules of fractions, we then do 5 root 11 over 18 multiplied by minus 18 over 7. So dividing by the fraction we multiply, and then we've got 18 becomes 1, so we end up with minus 5 root 11 over 7.
So when you have a division like that, and then you times it, you switch.
The basic fractions, if you divide by a fraction, it's the same as multiplying by the reciprocal of the fraction.
Can I just show you guys?
It's not going to be good for the video, actually. That's it in a second. Right, guys, any questions on that we need to talk about together? No? Okay, I will stop there. I'll let you carry